Mars. That is a hot topic, especially for me it is. I've always believed that there's more to Mars than just a dead planet. So tell me this, what is Mars like? And maybe give some of the similarities to Earth. Maybe compare the two.
Absolutely. If you look at the Earth and Mars, Mars is roughly half the size of the Earth, but it's a terrestrial planet or a rocky planet. So we only have 4 terrestrial planets in our solar system, and Earth and Mars are 2 of them. Mercury and Venus are the other 2. The rest of them are basically gas giants, so there's a lot of atmosphere and little or no solid ground. So Mars and Earth have a lot of similarities also in chemical composition and history. They were made of the same materials at the same time in the solar system, and so much of their material inside the planet and on the surface of each planet is very similar. The chemistry is basically identical, except we're dominated with oxygen and life, and Mars has a very thin atmosphere, nearly a vacuum, but it still has sky, clouds, precipitation, and weather just like we do.
I see. I've seen a lot of pictures, and lately people have been sending me these pictures that color was added to, I guess, and they say that the photos that we have gotten back are not real and that there's actually oxygen, blue skies on Mars. I don't know. What has NASA's research done in the way of the way we view Mars? I mean, is it can we have any faith in any of the information they give us? Because I know a lot of people are skeptical.
Well, we can have quite a bit of faith in most of it, and a lot of it you can verify for yourself in a fairly simple manner if you have some science background. We do know that the atmosphere is very thin on Mars, but we also know that the sky is often blue. Many people will think that that has to do with oxygen, but it really doesn't. If you had a pure, dry gas atmosphere of nitrogen or of helium or of oxygen or of almost any non-reacting gas, you would basically find the same thing, a blue sky, and it has to do with how light is scattered by air molecules, not by what it's made of.
No, I didn't know that.
Well, and
I'm getting
many
an
people,
education.
Well, that's a good thing many times. But a lot of people think it also is associated with the presence of water, and it isn't. But we can see something very interesting, and the Martian atmosphere does have clouds quite commonly. On the surface, there's often fog, snow, dew, and other forms of precipitation. But when we look at the clouds in the sky, NASA often tells us that it's ice crystals, water ice. But the Hubble telescope tells us otherwise. If you look at light, light sometimes has a property called polarization, and Polaroid sunglasses take advantage of that to cut glare. Well, ice crystals and water droplets each do a different thing with light, and the ice crystals don't polarize the light, so when the Hubble sees them, the clouds are not polarized. But water droplets do polarize the light, and half of the clouds that Hubble sees in the Martian atmosphere are water droplets, so it's liquid water and not frozen ice crystals.
Oh, wow. So then what happens? Does it hit the ground and then freeze, or does it never hit the ground?
Well, actually, it can. You'll remember the Phoenix lander that went to the Mars North Polar region a few years back, and it landed there and sent back some fascinating material, including the fact that they landed right on a sheet of ice that was buried under about 1.5 inches of dirt. One of the scientists on the team claimed that, yes, well, it could snow in the Martian atmosphere, but it would never reach the ground. Well, when winter came and the Phoenix shut down, they couldn't find it until after the snows had gone, and they found that the solar panels on it had collapsed, and that clearly was from the weight of snow that had landed on them. So we know that the snow can reach the ground, and the other proof is the fact that there are polar caps, so snow must be landing on the planet.
Oh, wow, that's interesting. Now, what's the weather like on Mars? I hear they get 300-mile-an-hour windstorms. Is that true?
Well, actually, no. We had 2 very good weather stations on Mars back in 1976, Viking 1 and Viking 2, and those landers carried wind speed meters, and no matter what, they never saw a wind greater than 74 miles per hour. And even with the recent Mir program, Opportunity and Spirit, when the dust storm struck, Opportunity was able to measure the amount of dust that was deposited because it had the camera right on the surface, and it was also able to measure take some wind measurements, and they never really saw anything over around 70 miles per hour under any circumstance. So while there are dust storms, the air is extremely thin, and even when the wind is blowing at high speeds, it doesn't have a lot of force. It's sort of like the difference between walking through a stream of water at 3 miles per hour or standing in the wind at 3 miles per hour. The water is so much more dense it can almost carry you along. Well, the difference between the atmosphere on Earth and the atmosphere on Mars is similar to that. It takes an immense amount of wind speed to carry any dust on the planet because the air is so much thinner than it is here on the Earth.
Now, why is the air on Mars so thin compared to our own planet? I mean, what's the difference? The size of the planet?
In fact, that's a very good part of the answer. The planet is so small that if you were to stand on the surface of Mars, you'd only feel about 38% of the gravity that you do on the Earth. So for something that weighed 100 pounds on the Earth, it would only weigh 38 pounds on the surface of Mars. Well, gravity is one of the major factors that keeps the atmosphere surrounding a planet. Without it, gas molecules that are hotter than the others will fly off into space literally by like a process of evaporation, and the air gets thinner and thinner. There is a satellite orbiting Mars called the Aspera 3, and it measured the rate of gas loss from the Martian atmosphere, and it loses about 100 tons of gas per day. Now, the Earth, of course, has much more gravity than Mars, but we also have another advantage, and that is volcanoes. Volcanic activity replaces the water in our oceans and the atmospheric gas in our atmosphere. So because Mars is basically geologically dead inside, it doesn't have any volcanism, so it can't replace its air or its oceans.
Oh, I think we just came up with the solution for the obesity problem.
Less gravity? Well, maybe.
Yeah, bring them to Mars. They'll feel better about themselves and they'll, maybe take shape. I don't know. They say there's a problem with that. What about oceans on Mars? Has there ever been, or is there now, any type of evidence of oceans?
Actually, yes. In the past, that was a big controversy, whether there ever could have been oceans on Mars. But when you take the orbital pictures from the satellites with the cameras that are in orbit around Mars now, you can see numerous river deltas and places where water has washed over the plains and left valleys and rills. You can see some areas that even today appear to be brine lakes here and there. Those would be very hard to evaporate and get rid of, or even to freeze because of their composition. But it is proven that there were huge oceans on Mars in the past, and that maybe up to half of the planet might have been covered by water. In the area of Opportunities Landing, Eagle Crater, that particular area in Meridiani, they found that the water might have been anywhere from 10 to 50 meters deep, and that's 33 to, call it about 160 feet of water on the planet. They also did a survey of the ice in the craters in the North and South Poles and also in the polar caps, and found that just below the soil there's a huge quantity of water ice today, and if it were to melt, they could give an average water depth of about 50 meters all over the planet. So the oceans never left. They're frozen. They're like glaciers right now. The Mars that we see today is really one in an ice age, and it's been frozen like that long enough that orange dust all over the planet has covered all of the ice sheets.
Oh, wow. So how can they tell how much of it is ocean? I mean, how are they able to determine that?
Actually, that turns out to be fairly simple. If you look at the map of the Earth with the water removed, you will see how the continental shelf, where the ocean basins are, has a different quality from the higher dry land that we know of today. And so the geometry of the land has been sculpted by the presence of water. And in many cases, you can see where, let's say, a river has run downhill, created a delta, and fanned out into the sea. It leaves a very characteristic series of riverbeds and curving valleys and channels behind it. And we see those same features on Mars in many areas. And in fact, the Curiosity rover, the Mars Science Lander, is presently in one of those areas, and it's known as Gale Crater. So they can see where the water pooled in the crater and exited and left basically running riverbeds dried up in its path.
That's amazing. Now, I did post those pictures that you had sent me on LateNightInTheMidlands.com. If everybody goes down to the bottom of the website, on the main page, I have a picture slider. And there's some pretty interesting photos down there. And there are fossils, I believe. But now you claim to have found fossils on Mars. Tell me a little bit about what you found, and I think that's just the most interesting aspect of Mars, I think, right now is all the stuff that people are able to, because with the technology we have now, to be able to go through these photos, I've seen some pretty interesting stuff, and what you got is pretty interesting as well. So if you could tell us about them.
Well, certainly. Back in 2004, I was doing some research for a project. We were going to build a rover of a sort that school groups and colleges could log in online and run a simulated mission. And in order to make it as realistic as possible, I was studying the images coming back from the rovers when they'd first landed. And I found what, to me, very clearly looked out of place. Now, I'm an avid rock collector and fossil hunter, and I have been since I was a child. So there were some things that in my eyes didn't look right. And when I started looking, you could see signs of what appeared to be marine trash, you know, bits of shell, that sort of thing. And the closer I looked, the more obvious it became. And so I did contact some people at NASA and discovered that they had a marine biologist, an oceanographer, on the team looking at the earliest images coming back, which was a very interesting piece of information. It turns out that the planet apparently went through the same sort of early history that the Earth did. And that shouldn't be too surprising because the chemistry would be the same. And very simple marine life showed up, and all of the fossils we find, to be very clear, are of a marine nature. Nothing basically that would have lived on the land. But when you think about it, on a planet where the atmosphere is so thin, anything alive is most likely to have an existence in an ocean because the water will act as a surrogate atmosphere. It will carry the gases that you need and the nutrients that you need, and you won't be exposed to near vacuum. So it made perfect sense, and the more we looked, the more we found, and everything was consistent. And NASA's stance has been very curious. Even though they admit they had people who studied and found traces of clay that were formed in the presence of water, and the chemistry was very consistent with the presence of oceans. For instance, all the gypsum rock that we find can only be formed in a low oxygen ocean environment in those deposits. Well, it tells you very clearly that there was water everywhere, and the fact that the planet is covered with rust. It's the red planet. How did it get rusty? It was wet. So we can see many signs that are clear even to somebody who isn't a real scientist, you know, deeply into the science of it. But you know, the most telling part was when they did an interview, a couple of years ago with Charlie Bolden and Phil Christensen, who was the head scientist on one of the rover instruments, the Themis. And what they discovered was actually in line with what I was publishing. And when asked the question, Phil Christensen said about my work, it's not out of the question. And that's the closest they've ever come to admitting that my discoveries are genuine. And one very strong supporting piece of evidence that I live with in everything I publish is putting the link to the original images on the NASA site. So anybody can look at the images and they can go back and verify for themselves that what they see is truly in those pictures. It's not something that's been doctored.
Right, right. Now, that's even more interesting, the fact that these could be fossils of sea creatures, because you look at, what is it, Europa, that's supposed to be all water, right?
Yeah, that's correct. One of the largest moons of Jupiter. There are 4 very large moons orbiting the planet Jupiter, and Europa is one of them. And Europa and Ganymede are essentially next door to each other, 2 of the big moons of Jupiter. Both of them have shells of water ice and appear to have liquid oceans inside that ice. One of the most fascinating things I discovered a few years ago was the information that that brown color present on Europa and Ganymede exactly matches the spectrum of bacteria growing on Earth.
Oh, boy, that is interesting. You know, I was just going over a story in the beginning of the show of a college kid who put together some report about binary star systems. And, you know, what he said made a lot of sense, that he believes that with the 2 suns, you know, that there would be a wider spectrum of a life zone. So, in other words, you know, a binary star system would more likely have more planets that could hold some kind of life than the single like we're in.
Well, that's a good possibility. It really depends on the configuration. If the two stars are orbiting very close together, then the planets have to be a little farther away, because when you have two massive objects, two stars orbiting each other, their gravity can add and subtract in an unusual way. There are bumps in the orbital path that can make orbits unstable. So your planets have to be a little bit farther out for those bumps to be small enough not to perturb their orbits or make them spiral in or get lost in space. But if the two stars are orbiting far apart, then each of them can have a small group of planets very close to them as well. We have a nearby neighbor, the closest binary system to us, Alpha Centauri A and B, which you can see in the southern hemisphere here on Earth. And they're a yellow and a yellow-orange sun. And each of them has the possibility of 3, 4, 5 small planets near them. They've already discovered that Alpha Centauri B has a planet orbiting it that is probably molten. It's a ball of lava, it's so close. So we know that it's possible.
That's fascinating. Yeah, so this amateur astronomer, apparently, he believes that there could be, and I thought it made kind of some sense. I said, well, if it was stable, yeah, I wondered that too. I thought if there's two of them, wouldn't the gravity, be that much more? But I don't know. Who knows? I'm not a scientist, but I thought it was interesting. Now, getting back to Mars with the fossils. Now, tell me why you believe these are fossils and not just mineral formations.
Well, there are a number of very clear signs for anyone who's a rock hound or a geologist. And one of them is all of these spherules, for instance, are almost all the same size. They're all within a very small range of sizes. And that's a number one giveaway. All over the planet, you would find the same size objects with the same geometry. Another one is everything that they have located, everything that they've imaged here, has a very simple, consistent message throughout. The markings on them are very similar, the sizes are similar, and when you find something outstanding, you find numerous copies of it. You see, erosion is a random process, and it won't produce the same markings on 3 or 5 or 1,000 rocks. It'll produce different markings because it is random. When you find many, many rocks with the same size and the same markings on them, there's a very good clue that something other than simple geology or chemistry is taking place. Another very clear sign, many of the fossils that I've found have pentagonal or 5-sided features. There are no natural crystals in minerals in nature that have 5 sides. They're all 2s, 3s, 4s, 6s, nothing of the 5.
I see. Well, what's your opinion on the faces on Mars, these monuments and these pyramids that people point out?
It's fascinating because when we look at it in light of the fact that the oceans are still frozen as sheets of ice like glaciers under the soil, in areas where the ice begins to melt or flow away, it creates a cliff. And the soil will slide down that cliff at what's known as the angle of repose. Now, the pyramids on Earth, particularly the ones in Egypt, were engineered to match the slopes of dunes as closely as they could so that they would not erode over time. And it's a pretty good strategy. You're going to find that dunes or sand falling off the edge of a cliff will fill it in at that same angle of repose, and it'll look very much like a pyramid edge. In the Cydonia region, I've looked at that in great detail, and it clearly has a sheet of glacial ice under there, and it has cracked and eroded away. And so what we're seeing is the soil slumping over the edges of those cracks. I really do believe those are natural and not artifact formations. And what helps us see that is we find faces on the Earth all the time when we look down with geodesy satellites, the ones that do weather and land surveys. We found a number of faces on the Earth that very clearly look like faces, and yet when we get there we find it's just a delta of a river or a fan of a mountain where it's eroded down. So it's not too unusual. I mean, the human brain is wired to look for certain details in things, and it's very easy to fool you.
Okay, but now, judging that there's there's fossils, I mean, there's always the possibility that there could be structures up there, right? I guess we won't know until we actually explore the whole planet.
Well, that's true. That is true. It would take an actual exploration mission to be sure. But I would like to point out something that about science and physics and chemistry. Organic life, life as we know it, to be energetic enough, to be active and intelligent, it takes a certain sort of energy availability, and oxygen is a very important part of that. We have found animals that will live with little or no oxygen, but they tend to be very simple things like insects or small crustaceans or worms. When you get into something that has enough intelligence, and a brain is an expensive thing to keep alive. It takes a lot of resources. So roughly 20% of your metabolism goes to your brain. Well, when you look at Mars and how lousy the environment is there, and we look at the fossils we found, everything seems to be very simple life that lived in an ocean. If you're finding artifacts of some sort, I can pretty much be, I'd bet that it would be something from somewhere else, not from something that grew up on Mars. I seriously doubt that anything with any significant intelligence ever emerged on Mars because the environment just would not have been proper for it.
So then you wouldn't think that maybe in the early days of Mars that it, because I've seen this thing on Weather Channel. I know it's the Weather Channel, but I watched this documentary they had, and it talked about how early Mars could have been similar to Earth. Not exactly like it, but close. I mean, they didn't go as far as to say there was life there, but that there was plants and maybe trees and things like that until it changed.
Sure. Well, and plants and things are life. One of the things I really got a laugh out of when I was a kid, I used to watch Star Trek, and they would beam down to a planet, and they would look all around, and there'd be all this lush vegetation, and the science officer's got his scanner, and he's going, well, there's no signs of life. And what he's talking about is animal life. Surely there was plant life all around them. So that's one of the things that sort of confuses people when we talk about life on another planet. Even if a planet was covered with nothing but greenery, you'd know that it was life and that it was an indication that life would be very common everywhere if you found just 2 or 3 examples of it. Life is very hardy, and it's likely to crop up everywhere you can imagine. I mean, one simple thing that puts a nail in the coffin of a dead universe is this. Most of the biological material on Earth is not in the oceans or on the land or flying in the skies. It isn't the animals or the plants. It's bacteria, and they live for miles underground in the rock of our planet, and they consume petroleum and natural gas and magnetite and other minerals. So most of the life on Earth is not what you're seeing. It's germs down in the rock, and it seems very reasonable that since these things can live in such incredible, inhospitable conditions, that probably they're common all throughout the universe, living in the rock of other planets and living everywhere in places that you wouldn't even think of.
So what do you think the likelihood is of developed intelligent life, somewhere throughout the universe? It's got to be pretty high, don't you think?
I would think that it would have to be very high. We're often told that the conditions for the development of life and intelligent life have to be just so and just exactly perfect. But I think that the conditions that we think of are the odd man out, and that life itself is going to be present everywhere. Nevertheless, we're going to find a lot of planets where there is intelligent life. And, I mean, people will argue about intelligence, but let's face the fact that you can teach your dog to follow voice commands, and a lot of animals are smart enough to figure out how to use tools like a stick or a rock to get something done. And that's surely intelligence. It just doesn't lead to radio telescopes and hand grenades and, power plants. But intelligence, is just the ability to react to your environment quickly and intelligently, to get yourself to survive throughout unpredictable conditions. We're going to find intelligent races, but I just don't know if they're going to be as common as many people think. I think that living worlds are very, very common. Intelligence, on the other hand, might be a bit more rare.
Right, and if I was to visit another planet and seen a dolphin, I would then declare that there's intelligent life on the planet because they're intelligent, they just don't have hands and feet.
Absolutely. I found one of the most interesting things about dolphins was that every one of them has a unique name. When the dolphin cries out underwater, he cries his name, and what he hears as his echo is the world modulating his name. That's how they can identify each other, and that's how they know what they called out and recognize their own echoes.
That's fascinating. That is. That's fascinating. You know, and again, there's intelligence. You know, it's just unfortunate they don't have hands to build things, I guess. Now, getting back to NASA, you said that they don't agree, or they do agree with your findings.
Well, officially, they don't believe that, you know, they state that they don't have any signs of life on Mars. The director of NASA, Charles Bolden, has stated that he believes there is life in space. You know, he didn't really give any reasons why he believed that, but I think that it's a pretty common belief among many scientists that life is common. I think that the issue that I take with NASA is that when they're presented with information that is fairly good evidence, they tend to turn away from it. For instance, the Martian meteorites, like ALH 84001, for anybody who follows the news on it. Back in '96, they had a meteorite that they claimed had what appeared to be fossils in it, and it was a piece of Mars. And they went back and forth with it, and they said, well, these molecules could have been, you know, created by inorganic processes, and they were given organic molecules, tracks through the rock, magnetite signatures, many different things that if you found that on Earth, somebody would say, well, that's clearly a fossil. But in every case, they refuted every sign and claimed that it couldn't be proof of life. Now, from a strictly clinical standpoint, I suppose you're right, but what point do you reach when you have so many different signs in the same place that the evidence itself becomes overwhelming?
I think they need an animal to jump in front of the camera of that rover up there and say boo.
Well, that would certainly answer a lot of questions, but it would raise them any more as well, I'm sure.
Yeah, it would. We're coming up on the break in about, well, another 5 minutes. So let me ask you before we go to the break,
Okay.
to you, why is the question of life beyond our world important? Why do you think it's important to most people?
Well, I think for most people it's just a fascination with what could be out there, the explorer urge. For me, it is, I think I would say it's a verification of my thought that the universe is a bioreactor. The universe is an incubator for life, that order emerges from chaos naturally. I have a good friend, Ed Minchow, who said to me that chaos is inherently unstable. And I think that's a very good way of looking at it. The universe takes chaos and converts it into order, and life will emerge everywhere. There's a little solvent like water, a little bit of energy like sunlight, and some chemistry to work with. So for me, we discover life, we might find new medical compounds, new ways of looking at genetics, new food or energy sources. There's no telling what we'll find. We just have to keep our eyes open and keep exploring.
Absolutely. And how do you think it would change society here? Say if the news came out tomorrow and says, guess what, folks, we found life. And it don't have to be intelligent life, but just life.
You know, I don't think it would change a thing at all. Just about half of every movie we've seen for the last 30 years has been based on aliens of some sort. And people are very accepting of the thought. What I find most fascinating is that other countries and other religious systems easily embrace the thought that there's life everywhere in the universe. It is specifically in this country that they have trouble with it, and I'm not certain why that should be. We are a very progressive technical nation. It should be the other way around.
Yeah, and a lot of those movies, unfortunately, the aliens always want to come down and eat us or enslave us or something. And I'm not so sure that's the way it is.
It couldn't be, and I'll tell you why. Chemistry. It's probable that our biochemistry would be toxic to them just as they would probably be toxic to us. You wouldn't be eating an alien, I don't think.
I wouldn't want to. Hang on there for a moment, Sir Charles, and then we'll come. Charles, energy. What exactly are you working on right now?
I've got a couple of projects going on. One is a little unconventional alternative energy system, but the one that I really am focusing on at the moment is a brand new design of windmill, something that I basically threw away everything people start with, the assumptions they make, and designed a whole system from scratch from basic principles. It's a windmill that uses louvers, and you'll have to actually see it to see how it works. But we took a trip last month down in the Caribbean for about 3 or 4 weeks and went to the islands down there, and they have constant wind all the time. And I thought, this is a wonderful place to start putting windmills so people can have systems that drive water pumps, electrical generators, and air compressors or refrigeration compressors right off of wind power. And so that's what we're really working on right now. We've got a big prototype built, and we're targeting it for a couple of thousand watts of power. And we're doing some research and refinement on it right now. So that's our big project at the moment.
Great. Now, what about free energy, that type of thing? Not that it's totally free, but like the Tesla coils and things like that. How much faith do you have in that stuff?
There are systems that produce a constant small amount of power. The expense and the nature of them sometimes makes it impractical. There are some people who build versions of what's known as the Tesla Radiant Energy System, which is basically a series of tuned antennas that picks up RF from the environment around you or static voltages and converts it to a small, useful amount of DC power. That can be done. But unless you really have the facilities for making like hundreds of these units and putting them together in parallel, it can be difficult to do at best. Free energy is such a bandied about term that I think people have lost the meaning of it. It's kind of like green or organic. You know, it's one of those things that's been used so much, people are not really sure what it even means anymore. But with free energy, mostly people refer to things like zero-point energy, pulling energy out of the vacuum, or harvesting energy out of magnets. And you know, there's a grain of truth in some of it and a lot of physics to fight on the other side. There may be systems like that that can be made to work. I know some fascinating work was done with light-emitting diodes and quantum mechanics a few months ago. They found a light-emitting diode that actually put out more light than the amount of energy they put in. But what was happening is it's harvesting the energy of random heat in order to do it. So that's a fascinating thing. If you could do that on a large scale, you could get cheap lighting for very little power, or possibly other things to happen along those means. But free energy really is a misnomer. Nothing is actually free ever. Even you know, even if you have photocells or photovoltaics, they're not free. They wear out over time, and it's expensive to harvest the power out of them and convert it to something you can use. What really kills you in cases of many alternative energy systems is the cost of the chargers and regulators and the storage batteries. I know people who have put $70,000, $80,000 in solar systems for their home, and it's going to take them 25 years to pay it back.
Yeah, I believe Art Bell, back when he was on radio, he talked about that, and he said something around that. I think it was 20 years before it start paying for itself. And then you got other things to think about, too, like hailstorms and stuff like that. It can get pretty expensive.
That's true. When you look at something like photovoltaics, they're basically thin, fragile bits of glass of a sort, and all you need is one good hailstorm to ruin your day.
Right. You know, last year we were traveling. We hit like 10 different states, passing out cards and flyers and all kinds of good stuff. And we got into Indiana, I think it was. It was late at night and really dark, and I seen all these lights. I mean, we thought that we had just entered some kind of space-age airport or something. And they were actually windmills, these big wind turbines. And there was just fields and fields of them, and I never seen nothing like that before. It was pretty wild looking. So how efficient are those? I mean, is that type of energy the way to go, or what?
Wind energy can actually be quite effective. You know, I'll give you an example. In Texas, in many areas, the density of wind energy is twice as great as the density of solar energy. So it makes far more sense to put windmills in those areas than solar collectors. And that's true in many parts of the country. One good thing about wind is it blows at night. So, you know, you're not dependent on the sun being up. But the one thing that I see that really gets me about those giant industrial windmills is that they have this huge area that the blade traverses, but the blade only cuts in about 4 to 6% of that area. In other words, for all the wind blowing through it, only 4 to 6% of the wind energy can actually turn the blade. Look at a farmer's windmill. It's got about 85% of the area covered, and it produces, in just a small windmill, enough force to run a water pump to take care of the cattle or the farm's vegetable watering needs. And those things were made over a century ago. They work just great. you would think that the same sort of design, where a great amount of area is being pushed by the wind, would be far more efficient, and simple tests show that it is. So you look at these giant windmills, and you look at how inefficiently they gather the wind, and then the fact that they're only up 40% of the time and down 60% of the time for maintenance. It looks like a very, very bad design. And, you know, they kill a lot of birds. People get concerned about that. Some areas they're banned because they interfere with defense radar installations and airport radars. And really they're designed at the very edge of what the materials can handle. Wind speed goes up, a lot of those blades start vibrating, and they'll snap that fiberglass and aluminum right off. They can be a real disaster. I mean, it's wonderful that they're trying to harvest wind energy, but it can be done far more effectively than what they're doing.
Yeah, we could send a man to the moon, but we can't find a decent, safe way to harness wind energy. Fascinating.
We can't even send a man to the moon anymore. So, you know, it looks like we're moving backwards in some respects.
Yeah, we absolutely are. Now, where do you get your research projects from? Companies or private organizations? How do you go about that?
It's a little bit of everything. Sometimes I'll take on a job just for fun. Sometimes I'll be asked to do a specific job for a company, develop something, or work under a contract. Some of my research is funded by private organizations, but almost always the ideas come from things that I'm inventing and, you know, just ideas that I have. I love science and physics, and it's just fascinating to see how much we can do with the world around us. You know, we have everything we will ever need to make everything we'll ever need. I mean, we've got everything, and we can solve every problem. To me, it's just looking at the world like a big puzzle and seeing the opportunities in it. Presently, one of our jobs is being paid for by outside investors, and a couple of the other jobs are being done completely in-house.
I see. So now what do you think the most important work that must be done to make some, well, affordable energy, I guess?
Well, I see three different things that we can do that will really bring the cost of energy down. One of the most important ones is storage systems. You know, you can have all the alternative energy and solar and wind systems in the world, but if you don't have a way of storing the energy once you've harvested it and then getting it back again when you need it, it doesn't do you any good. Nobody wants to watch TV just when the solar panel is working or just when the wind is blowing. So, you know, we put battery banks in. But batteries, generally you got toxic, corrosive chemicals, heavy metals, hydrogen venting, and they're hard to maintain, and they only last a few years, then you got to buy new batteries. The biggest thing we really need to do, number one right now, is better storage systems. They have a material called graphene, which is a form of carbon, and it looks like it might be the answer to new storage capacitors that will be more effective than batteries. I see that as probably the number one thing to look into investing and working on right now. Another one is we have to look at other ways of generating power. Right now, everything we do is either nuclear or burning stuff. And it's pretty obvious that if you're burning stuff and it's not being replaced, you're going to run into a problem at some point. I know a lot of people are really unhappy about the amount of coal and petroleum we use, and rightly so. There are limits to how far you can go doing that and how dirty you can be doing that. So we really need to look at other ways of generating power. And alternative energy is one way to go, but it's really, really tied to those storage systems. The third thing that I see that we really need to look into is how we apply the power we generate. If you're doing something that requires heat and you're working on alternative systems, then solar is probably the way to do it, like making hot water. If you're looking at something that needs compressed air and you're off the grid, use a windmill or some other system or a water turbine to run an air compressor. A lot of times, the sort of energy we need, whether it's light or heat or whatever, can be gotten very efficiently. I mean, 30% of the power for your home generally goes to heat water. And so you wouldn't do that with solar cells. You'd use a flat panel water heater. And that can be much, much cheaper, and it can cut a huge chunk off your bill. And that reminds me of something. Did you know that the average household uses about 6 cubic meters of water? That's 6 metric tons of water a day. Only one of those cubic meters of water goes to bathing, washing, and everything else, family and personal use. The other 5 tons of water is used at the power plant making your electricity for cooling and circulation purposes. If you generate your own electricity, you're saving 5 tons of water and only consuming 1. So you can reduce your usage of water on the environment 6 to 1 by generating your own power.
I'm all for generating my own power, believe me. I wish somebody would come up with the perfect contraption so that I can, go out and, well, not me personally, but get the wires snipped.
Well, I think it's in the wings.
Well, I hope so. I'm really concerned with the nuclear power plants. That's a power source that really concerns me deeply. I mean, you look at Fukushima, and then here I'm in South Carolina, and we've got a lot of those things here. And, with the way the Earth is going through some changes, and increase in earthquakes and storms and all this stuff, I'm really concerned about those. Because if we have, say, an EMP from the sun or what have you, we're in trouble.
Well, it's interesting. It really is interesting. I did work on and off for years on nuclear stuff, including nuclear weapons, and I also worked with a group called the Nuclear Design and Test Lab for a while, many years ago. And we found some very, very fascinating stuff. Number one, people are mostly concerned about the threat of a meltdown or some nuclear disaster, but also, number two, about the nuclear waste generated in the process. And it's interesting because if you put it into perspective, a 1 gigawatt reactor, that's 1,000 megawatts, a 1 gigawatt reactor produces enough nuclear waste to make about 1 cubic meter in a year. It'll fit under your dining room table. That's not a whole lot of material. But what is most fascinating about that is this. 2/3 of that is still usable fuel. And in this country, it is illegal to recycle nuclear waste. You see, the technology to do it has been around all these years, but they made it illegal. That's why we have nuclear waste. Waste is really a misnomer in this term because in this case, the material could be turned right back into fuel. And of the stuff that you extract that isn't usable fuel, a tiny amount of it can be extracted and used in industries such as medical treatment, non-destructive test. There's a use for every bit of it. And the low-level stuff that's left over, in 6 months it decays to the point where it's landfill. Many countries in the world are very much more progressive. France is, I think, 98% nuclear, and they don't seem to have a problem because they recycle their waste. Germany recycles their waste. Russia does. The United Kingdom does. We are just about the most backward country in the world when it comes to it. And, you have a very...
It comes to a lot of things.
yeah, a lot of things. When you come down to it, the Fukushima incident was really like the perfect storm. Here you had outmoded design reactors that can melt down, and they were built in an area where there are earthquake faults, and it was subjected to the threat of a tidal wave. Anybody with a brain in their head would never have done any of those single things, and they did all three of them in the same spot. And what gets me is that they did build those plants that can melt down. In Canada, they have a meltdown-proof reactor called the pebble bed reactor. And it's a design that's been around since the early 80s, and we just don't use it, and I don't know why. Basically, in a pebble bed reactor, you can yank the control rods out and run away, and it cannot melt down. It limits its own temperature. The fact that we continue to build reactors that can melt down shows that somebody is a real idiot somewhere. We've had the answer to this for decades, and it's just not being done.
Absolutely. I can agree. If there's a safer way to do it and they're not doing it, that's just, it don't make sense, but I'm not surprised. Now, why would they make it? It does, and that's probably why they make it illegal to recycle the waste.
That wouldn't surprise me.
What would be the reason? Okay.
Well, I know that they did allow, military projects, military applications can recycle their waste, but I think that the biggest thing was the fear that was instilled in people of the possibility of someone getting their hands on nuclear materials. If this is done properly, it's just not going to happen. We don't see it happening in other countries.
Right. Well, I just as soon get rid of them altogether. We know that there's better ways. It's just a matter, again, the dollar. You got the oil companies. They don't like any new ideas if it excludes them. The power companies, if they can't sell it and put a meter on it, basically, you know, it's going to be like pulling teeth, I
Certainly.
guess. Yeah. So let's take a call, Sir Charles. We've got Kathleen in Florida. Kathleen, welcome aboard.
Hey, everybody.
Hello.
Hi.
I was really interested in your Fossil Hunter's Guide to Mars.
Yes.
And when you talk about that, have any of these ever come back to Earth, or they just noted on photos of Mars? Have we gotten the actual substances of any kind back from Mars that you know of?
At this point, no samples have been returned from Mars, but there are very good reasons for that. They have a sample return mission planned, but the issue that many people take with that is this. If the sample they bring back contains any biologically active material, a bacterium, a fungus, a germ, and it gets loose on the Earth, we have no immunity to that, and it could be something that could be harmless or it could be absolutely devastating. My biggest worry about that is that if something came back that found itself at home in the oceans, like a diatom, it could begin to grow without competition because it wouldn't have any natural enemies here, and it could wreck the food chain from the bottom up. I would be very, very concerned about bringing back anything in a sample from Mars.
Right.
Ooh.
And,
yeah, I never really gave it thought. That would be horrible, but go ahead.
When you see a lot of these pictures from Mars, you see all that kind of brownish, reddish, dusty-ish kind of like everything on the surface.
Sure.
There's a video that I've watched, and it was very fascinating. I don't know if it's legitimate or not, but this gentleman took pictures from NASA, and he went up and down within the Photoshop, of course, with the coloring, and he pretty much pulled out all the browns and the reds and stuff and kind of brought focus in. And he did quite a study on some of these photos, and they were just absolutely amazing. There were so many clear pictures of what I would term as like beings. Nothing really looked human-like. Everything really looked animal-like or amphibian-like. And the colors that he pulled out from Mars were so vivid. They were beautiful reds, very deep, vivid reds, beautiful oranges, purples, blues, every color of the spectrum. And these are so clear, like about the faces and everything, are so clear that these look like things that are actually maybe painted or something. And they must be tremendous.
You know, what's interesting here is that the interpretation of color is sometimes difficult based on the conditions of lighting and the device you're using to take the pictures. Now, what I did when I downloaded the original images is I looked at the photo, the filters they used, and the wavelength of light that those filters would pass. And, you know, the funny thing is, years ago as a teenager, I worked in a dark room, and I did color separations for a print shop. And so I learned how to do densitometry and color balancing very early in my life. And knowing, you know, little knowledge of optics and physics helped a lot. By assembling those pictures by the calibration standards that NASA used themselves, I came out with an amazing set of very clear color pictures, and many of them are posted on my site, schultzlaboratories.com. There is a blue sky, and many times of the season and many times of the day. The colors are muddy and reddened in many of the images, and some of the ones that they released early on, particularly one of Burns Hill up in the Endurance Crater, you look at it and you can see it absolutely was photoshopped. They corralled the sky. They painted it one single color with no grain in it, and you go back to the original filter images, and there's plenty of grain and differences in the color. You can see that it was manipulated. There's no question about it. So the question that does come to mind is why? It doesn't make any sense. If this is real science, let's see the actual color data.
Right, that's what I say.
Absolutely.
Seems like they're covering something up or covering things up. And then the other question I have is, I've heard a lot of stories lately and read a lot of stories lately about some people jumping through different contraptions from the Earth to the planet Mars. Do you find any truth in that? Is that a possibility that humans may have actually landed on Mars and then did whatever they did up there and came back and did it several times?
Well, this is an interesting question. This is a very good question, because right now when we send a spacecraft to Mars, we have to wait so that it's in a certain position with relation to the Earth. As you know, we're on two platforms that are moving through space in big circles around the sun, and they're never quite in the same place twice. So you have to be aware of how long your ship's going to take to get there and where that planet is going to be at that time. Planning a mission to Mars generally means a 7 to 10 month flight right now. And that's because when you fire a spacecraft, it is only powered by the amount of fuel that it can carry. So it has to go on what's known as a ballistic flight, like it's thrown, and the engines are there just for correction and then for speeding up or slowing down at the beginning and end of the trip. For a human being to go to Mars with the given technology we have today, they would have to take in about half of a lethal dose of radiation from space in that trip, and that would take them about 7 to 10 months. So anybody who went to Mars using our existing spaceship technology would not be able to return safely to the Earth. They'd be stuck there, or they'd die on the return trip.
So I guess what I was referring to is the Project Pegasus. Do you know what I'm referring to?
Yes, I do, and it's there are many proposed theoretical ways of getting to the planets. Right now, to the best of my knowledge, we don't have any of them working other than rocket propulsion and some simple ionic propulsion. I do have an engine design that I worked on for years, and I would love to see built one day, and I'm working towards that. That would be a plasma engine with an exhaust temperature of around 50 million degrees Kelvin, and it can be powered by solar collectors. So what makes the most sense to me is this. When you're in space, the sun is shining all the time, and that represents a real source of energy. If you have the ability to collect and focus that energy, you have the ability to drive a spacecraft engine. And so why this isn't being done is really a very good question, but I think that it will probably show up within the next 3 to 5 years. Somebody certainly is going to be thinking of this and doing it. In a small form, it was done with the Deep Space One spacecraft, the ionic propulsion spacecraft. A friend of mine, Michael Fulton, was instrumental in doing the solar power system on that.
Well,
maybe the Tesla technology or the Pegasus project might be something that may not have occurred.
I don't think that it's anything that is actually a working project at this point, no.
Well, it was in the past. It was actually in the past, I suppose, the early 80s, I suppose, where this was supposed to have taken place.
You know, it reminds me a lot of the old Orion spacecraft. You know, we hear of the Orion now, and we think of the new moon ship. But many years ago, starting back in the 60s, the Orion was thought of as a ship that would be powered by exploding nuclear weapons behind it. And it certainly would have worked, but boy, would you make your neighbors unhappy.
All right. Anything else, Kathleen?
Well, I don't know. I question the whole Pegasus project, and I really do. So that kind of clears that up for me. Thank you very much, by the way.
You're very welcome. Thank you for calling.
Thank you, Kathleen. And as far as the Pegasus project goes, I cannot confirm nor deny it. It's a wild story, and I know that the individuals involved really believe it. Who am I to tell them it didn't happen or it did? I don't know. That's some fascinating stuff. And Sir Charles, they are planning this reality show on Mars where these people are getting together, people apparently for a one-way trip. And what do you think about that?
I think it's going to be rather interesting. Again, the one-way trip is because of the radiation dose. There are some key players in the field of traveling to Mars right now, and Jeff Bezos of Blue Origin had the goal in mind of putting a greenhouse on Mars a couple of decades ago, and he's actually seriously pursuing that. Peter Diamandis is another one, and of course Robert Bigelow. He's got two small space stations in orbit around the Earth right now, and that's something that strangely the news won't talk about. Many people are involved in efforts to get to Mars and to get to the Moon, and to do it in a commercial manner. In other words, to make money at it, to make a living at it. There are companies that are now targeted at mining the asteroids. We're going to see this happening in just a few years, and the proof that it can be done really happened when the X Prize was won. Burt Rutan getting Spaceship One to carry, to do 3 flights within a 2-week period, that was the tip of the iceberg. Now we're going to see, basically, if economics and government will get out of the way, we're going to see the barnstorming era of space very shortly here.
I see. So if they can come up with a better way, maybe these people can go and come back. But at this point, it would be just a one-way trip. I mean, would they be able to set up maybe some kind of greenhouses and grow stuff and do that? I mean, would they be able to sustain themselves at all?
Absolutely. The funny thing that people have always concerned themselves with the environment on Mars and how difficult it would be to create food and water and a lot of other things. Well, Robert Zubrin, the scientist, wrote an interesting thing back in I think it was about 1990, 85 to 90, and it was about going to Mars and using the energy and resources to create everything you need. We have made many advances since then. We do know that the soil on Mars in some areas is quite suitable for growing vegetables. The Phoenix lander at the North Polar region found that the pH of the soil was perfect for many earthbound vegetables like asparagus, and that's a very good sign. So, the minerals are there. We know what the composition of the soil is like. If you had nothing but an air compressor, you could suck in that thin carbon dioxide atmosphere and turn it into high-pressure gas for a greenhouse very readily. The only thing you have to be careful about is meteorites. And for that, you would burrow underground and put about 1 or 2 yards of soil on top of your habitat. And you'd use light collectors and bring the light in by fiber optics, and you'd be able to have sunlight and gardens underground where it's shielded. I think that you could live a very good life on Mars, and it could be done with the existing technology we have today.
Wow, that's pretty interesting. So then, by theory, there could actually be a base on Mars right now, and people could actually live there. So, I mean, this can be done.
Well, if we could get there, yeah, it certainly could be done. It was pointed out years ago, critics of the ability for us to sustain life in a closed habitat were saying, you couldn't make a space colony big enough to support like 100 or 200 people for a year all sealed up. And other people pointed out that we do it with nuclear submarines all the time. If you could transport a nuclear submarine to Mars, you'd have a perfect base.
Wow, that's interesting. All right, hang on again, Sir Charles. We've got, before we're done here tonight. And we will go to the phone lines here in just a minute. Sir Charles, I want to ask you a quick question about the environment before we take our next call, and that is about carbon dioxide and what type of threat that actually poses for the environment. Now, me personally, I believe that global warming, call it what you want. I think the Earth is definitely going through some changes right now. I don't know. We're not helping matters any, but I don't know as though it's all because of humans. But what do you think?
Well, carbon dioxide is an essential part of the environment, actually. The funny thing is, when carbon dioxide levels go up, plant growth increases, because most plants have to have some minimum amount of carbon dioxide to grow, and if you give them more, they grow faster. All of the food for all of the animals on Earth comes from plant growth. So another interesting thing about carbon dioxide is if the temperature goes up due to the presence of carbon dioxide, more evaporation occurs, so more moisture ends up in the atmosphere. The system is really a lot more complicated than people think. When the temperature goes up, more clouds can form because more water has evaporated. More clouds makes the globe brighter and more reflective, and so it cuts down a little on the heat reaching the globe. The system actually regulates itself to a great degree. Now, yes, we're adding a lot of carbon dioxide, but a couple of volcanic eruptions far outweigh the amount of carbon dioxide that we put into the environment. So it becomes kind of a tricky thing to resolve. Years in the past, we couldn't tell how much carbon dioxide was in the environment. We have to estimate it, or they take readings from bubbles of gas in ice caps, and they say, well, this represents how much carbon dioxide there was at that time. It's really impossible to say just how much is from human intervention and how much is from natural forces at work. But we do know that we have made some changes in the environment. We also know that the planet naturally goes through cycles, some of which last hundreds or even thousands of years. I would state that, to be absolutely honest, we haven't been around taking data for 500 or 1,000 years. We really don't know what part of the cycle we're on or what's really happening at this point.
Yeah, well said. I agree. But I don't think it could be denied that we're not helping this planet any. When you take the Fukushima alone, not good. I mean, you think about the radiation going into the ocean, not to mention all the other pollutions. You know, I look at Earth as though it's this living organism. And, you know, we're like these ticks on it. And eventually, you know, that immune system's going to kick in. You know, we're making the planet sick. Don't you think the planet might react to that? Maybe, you know, say bye-bye humans.
Well, you know, that's a good way of looking at it, and it's a good way of creating an image people can identify with. I think that the reality is, if we do something that changes our environment enough, it's going to cut our food supply off. It's going to change things that make our survival impossible. And it won't necessarily be because the planet chose to do something. It'll be just a natural consequence. It's like climbing a rope ladder while you're sawing on the rope. We have to be very, very careful about what we are doing, and we're not yet wise enough to know what those effects might be years down the road.
Absolutely. Now, how do you think we go about reversing growth in desert areas? I mean, there's so many areas that they say, archaeologists and different researchers say used to be all green. And, you know, now they're deserts. I mean, we can actually do something like that? We can turn the deserts green?
Yes, we can. And it really isn't that terribly complicated. Now, a lot of people would say, well, let's just go out and irrigate a desert. Unfortunately, it's not that simple, because one of the problems with desert areas is salt that shows up in the soil. So you can't just water it, because then the salt is still present, and only certain species of plant will be able to survive under that sort of condition. But what we can do to halt and reverse the growth of desertification, the areas that are becoming desert and unable to be farmed, is we go to the margins of them, we start mulching them, and we get grazing animals in there. I saw a fascinating report by a fellow who worked with elephants and herd animals, and discovered that by removing cattle and elephants and other grazing animals from areas, we were actually destroying the growth of the grass. The grass and those grazing animals work together in a symbiotic relationship. And when you remove grazing animals, like let's say people are saying when you cut down on the beef industry, well, unfortunately, when you remove cows from a grazing area, it stops producing grass, because the grass grows because the cows' emissions are trampled into the soil, and the grass that they trample down mulches and keeps the moisture in the soil so it doesn't dry up. So it turns out that it is a relationship between those species that makes the grasslands grow. And when we start removing grazing animals in a hope to save the grasslands, we're really destroying them instead. And, you know, that brings me to another point. We are being hit with these carbon taxes and carbon credit regulations and all of these things to help, you know, cut the CO2 emissions and take control of the problem. What I see is this. If they were really interested in fixing the problem, they'd be planting something. And I don't see any of that happening. And it starts with basic, decent farming practices. You start mulching and irrigating and planting. That would solve 90% of your problem right there.
I see. And with that, let's go to the phones. We've got Rita in New York. Rita, you're on the air.
Hi. I don't have anything to say about Mars, but I did want to talk to the American public about what's going on today with the government, the tapping of our phones, the illegal tapping of our phones, and I want to bring up something that happened to me a few years ago, which leads me to believe that my phone was actually tapped. I was living in Babylon Village on Long Island in New York. In that day, we had a senator. His name is Owen Johnson. He lived in West Babylon, and his office was in Babylon Village, where I lived. I had gone to the Babylon office, and the man who takes care of everything in Babylon, I said, listen, there's trees growing over my property. It was on Babylon Village land, dropping berries and dropping branches, ruining cars. And I said, somebody has to do something about it. It was not our landlord's problem. And the man said, oh, I'll look into it, I'll look into it. 3 years. 3 years. I kept going back to him. He wasn't there. He was not available. I called the mayor. No call back. And I knew Senator Johnson's office was right in the village. So I went into Senator Johnson's office one day, completely fed up, 3 years later, and the secretary asks me, what's going on? Now, his office was 5 feet from her desk with the door open. He was sitting right there. I saw him. I sat on her thing and I said, on the bench, and I said, listen, I've had this problem. I live in the village for years. There is this stretch of land that does not belong to the village and is a state problem. Nobody will cut the branches. When hurricanes come, they fly off the trees, damage cars. Nobody's responsible. Insurance can't be collected. I was fed up. So she said, well, it's really not the state's problem. She said, but I will tell Senator Johnson and see what he can do. So I said, okay, and I walked out of the office, and I knew he heard the whole thing because the door was wide open. I'm telling you, within 3 hours, the mayor of the village called my house, screaming at me, why did you call the senator? How dare you? Why didn't you come to me? And I said, I've been coming to you for 3 years. You never returned my phone call. I didn't even say, how did you know my phone number? How did they know my phone number? I had no clue how these people knew my phone number. The very next day, a slew of trucks, 3 to 5 trucks with tree cutters came and cut down all the trees the very next day.
Well, I'll be.
So,
well, I guess they took care of it then.
And, well, I guess they've been tapping phones for a really long time.
Oh, yeah, they have.
Right? And they don't look into that unless something happens. Like something happened this last time. And the guy reported the phone tapping from the NSA or whatever, and so now they're looking into it. But I think they've been tapping phones for a lot longer than we're even aware of.
Oh yeah, I believe they've been doing it for a long time. That's why I've told people for a long time, for at least the last 5 years, I've told people, if you don't think you're being tracked, no matter what site you go to or what screen name you use or what phone service you use, you're being, they're keeping tabs. No doubt about it.
Absolutely. Yep. And another crazy thing, I believe, it was, my cousin had died back then, but remember the entire eastern seaboard, the cell phones were cut off, and they said that, like, some big thing blew up in Massachusetts or wherever. They kept all the tower stuff. Do you remember when everybody's cell phone was just gone on the eastern seaboard?
Yes,
I live
I
here.
do.
Okay, so guess what? Our landlines worked. Our landlines worked, and this was, cell phones were not as big as they are today, but almost everybody had them still. Most people communicated with their cell phones, and people didn't even try their landlines. I had mine. I tried mine. It worked. I called my mother. Anybody who had a landline was still connected. So the one thing that I can think of is that millions of more people have landlines than cell phones, probably even still. I would say like farmers, people who live in the country, and there's many of them, still have the old landlines. And I think that that's an old form of communication that for some reason they can't tap everybody. Maybe it's more expensive. I don't know what the problem is, but I'd rather have a landline than a cell phone because those are easy to tap. They can plan something in it, and that's that. Yeah. So I think
agree,
that
Rita.
You do?
Mm-hmm.
Yeah.
No,
so
I do. I'd rather have a
emergency,
landline myself.
Yeah. Yeah. So that's what I wanted to tell you callers, and I thought it was really important.
All right. Well, I appreciate that, Rita. And, hey, if you're listening in tomorrow night, we've got Peter Kling will be with us, and we'll be doing World Watchers. Feel free to call in. We'd like to talk about it further, for sure. But at this point, we're trying to stay on topic here just for a little longer. Sir Charles, what do you think about the whole – do you have an opinion on this whole tapping the phone lines thing?
Well, there's no question that just about everything you do is recorded today. I mean, there's so much controversy about it not because it happens, but because so many people seem not to care. I think it's because most of the people who live with the technology today were brought up in an environment where they've always been told that, and they never think twice about it, which is really a shame. One of our basic liberties is the ability to communicate with each other without having prying eyes and ears applied to it at all times. It appears to be one of those things that's just fading away, and nobody seems to be protesting about it. Why do people in this country have to worry about every word they say? I don't think that's right.
I don't either. Back with the landline phones, it brings up a good point. I'm one of those who I just as soon have the phone in the house. So when I leave the house, nobody could bother me. I'll check the machine when I get home. But at least then, if your phone was being tapped, you'd hear like a clicking on the phone. You'd know if somebody was listening in or whatever. And now with the cell phones, I mean, they could turn them on. You could have your phone off, they could turn it on. And they could listen to you. I mean, this is real.
That's true.
I haven't had a cell phone in about 2 years now.
Well, let's hope it's not because of bad service terms.
I didn't want all them Verizon people following me around. They got a little old. So get back to the global warming. How real is it? I mean, I think the whole Al Gore thing was overboard, but all in all, again, we're going through changes, but do we really know how much of this whole global warming thing is real or what the results are or what's causing it?
We really don't. One of the things that comes to mind for me is that we've been monitoring a specific polar cap for a number of decades, and we see that polar cap is getting smaller and the planet is getting warmer, and we start thinking, well, maybe it's industry. But no, the polar cap of Mars is melting, and we certainly don't have SUVs or factories there. When we notice that there are storms in the atmosphere of Saturn that appear to be very intense and spreading, and we have to question what's causing them, we also know that it wasn't caused by industry because it's a completely different planet. The one thing that all of these planets have in common is they all have the same sun. For me, it seems fairly obvious that the answer is it's not the environment changes we're making. The one thing that's in common is they all have the same sun, and the sun itself is undergoing some changes. If we were to stop and look at the root causes of things, I would be more inclined to believe it's that than something we're burning and throwing in the atmosphere.
Yeah, see, and I'm no scientist, and that's even my belief that the sun is a big factor in the changes that are happening. Now, I have some who will contact me on a daily basis and tell me that it's because Planet X is behind the sun or near the sun. What do you know about this Planet X ordeal? And you probably don't put too much into it, I'm taking.
Well, I'll tell you, there's a very good reason for me not believing in it, and it's this. Something the size of a planet would be visible. If there was a planet out there floating around, we'd see it. Because even if you don't see it with an optical telescope, it's going to have an infrared signature. We're very good at spotting things. If we can spot an asteroid a couple of 100 meters across or smaller, we can certainly spot something as big as a planet.
Well, the word is that they've spotted it, but they're not telling us about it.
That's an interesting thought. It would take an awful lot of people walking around going, "Shh, don't tell anybody." I don't know. That strikes me as being a bit unrealistic, because what would anybody gain by keeping it quiet if they felt that there were a threat or something that might be? If I felt my family was threatened by something, I would talk to them about it. I don't think that an astronomer or anybody who's a real scientist researching real phenomena would keep something of that nature silent if they thought it were a threat.
Well, there's an answer for that one, too. It appears that scientists who do have data on this wind up, they turn up missing, shall we say. Now, this is just what's out there. I'm not debating you on it.
Yeah. Well, and it's interesting because a few years back, there was a whole spate of scientists disappearing or ending up dead, in particular ones who did research on certain fields of energy or certain fields of astrobiology. And even today, it's hard to say exactly what the causes of their deaths were. Many of them died under very suspicious circumstances. Last count I heard, there were 150 scientists in closely related fields who had vanished or shown up dead. It's a very disturbing trend. Science is supposed to be an open field. It's supposed to be an honest pursuit and one that allows us to increase our knowledge. And when people stand in the way of your increase of knowledge, they're not standing in the right corner. This is something that is absolutely terrible. The only thing that allows humanity to thrive and persist is that we can increase our knowledge. We can change the way we live, and we have the tools for dealing with life from an intelligent and pragmatic way. Knowledge is our power. We need knowledge, and anyone who'd stand in the way of it is a tyrant.
Absolutely, I agree with you. And I do remember back in '83 reading in a science little science magazine that they passed out in class, and and this was something that NASA had given the name to. They were looking for it apparently, but they never. I don't know as though they found anything in our solar system, but I know at the time, now they're saying there's rogue planets all over the place and dwarf stars. So I guess it's possible. It's just, everyone, I get all these pictures. Oh, I got pictures of it. I see it. And I'll go outside and I take pictures and I do all the little tricks they tell me to do. And me, myself, I've not seen it. And if I did see it, I'd tell everybody about it. So I don't know.
The issue of rogue planets is a fascinating one, and one that was hotly debated for many years. What they ended up doing was looking out deep in the solar system with infrared cameras and looking for heat signatures and one other fascinating thing, star twinkling. A planet is a dark body, and it will blot out stars behind it. And even very distant ones that are too small to resolve can blot out a star when it passes in front of it, and it can be seen that way. So it has been shown that there are planets outside of our solar system, very far away, that can be detected by this twinkling method. That's an interesting way of spotting something that you can't see any other way.
And these are just rogue planets that are just traveling through space, huh?
Yes, that's correct. There appear to be quite a few of them out there in the dark, and they don't have a sun that they follow, or they're so far away from it that they can't orbit it. They may have been ejected into space by, let's say, another star orbiting their sun, or possibly something passing by their solar system. Different stars pass by our solar system over the course of millions of years, And the stars in our neighborhood are not the same ones that were there 50,000, 100,000 or more years ago. There is a change in our neighborhood all the time. So it doesn't surprise me to discover that there are rogue planets out there. Not everything's going to stick around a star if another star passes close enough to perturb it and throw it out of its orbit. It can happen.
Yeah, that's something else I seen in a documentary. Is it was one of those what if a rogue planet, you know, came through our solar system and got close to Earth, and they talked about how it could knock it, you know, either slightly or completely out of the inhabitable zone, and that how the weather would change, and we'd have a different view of the stars, and not something I want to go through, that's for sure.
Well, it certainly could make life very unhappy.
Yeah, absolutely. Matter of fact, they speculate that that's what could have happened to some of the planets in our solar system now, that maybe at one point there was more, you know, maybe another one or another two that might have been in the inhabitable zone somehow. I don't know. Something came through and moved it, but we'll never know, I guess.
Yeah, it's a little hard to backtrack on something that doesn't leave much of a trace behind. That's an issue.
Yeah. So last but not least here, what do you see as being a real solution to the issues of the climate? You know, we've got a lot of species that are dying off on a regular basis, and of course some are concerned with population growth, while others say it doesn't matter. I think there's plenty of room on the planet for the people that are here. I think it's the resources that might be in danger. But what do you think?
Well, you're absolutely right. The way we use our resources is going to be a key to how we survive. And realize that in times past, disasters have occurred on this planet that destroyed up to 90% of the existing species. Many people are familiar with the death of the dinosaurs 65 million years ago and how terribly uprooted the biosphere was. I think that it can be sort of a relief to know that the planet tends to balance itself out eventually, but on the other side, we need to develop our method of husbandry, if you will. We have to be careful about how we affect the environment, and we have to be very aware of what we've done. Drugs that we have in our medical pharmacopoeia end up in our water supply, and they actually appear to have an effect on organisms because they don't break down very easily in the environment many times. They found all sorts of medications in the water supply that have been there because these drugs have been through the water table and back up again. We have to be very, very cautious of that sort of thing. The other thing is we have to know what's causing the change, and we don't even really know how our climate works fully at this point. It's going to take decades or more before we truly understand it and are able to, at some point, control it the way it should be. You know, and that raises another interesting question. If we have the ability to control the climate perfectly, do we? Do we do it? That itself could ruin a lot of life systems on the Earth. A lot of biospheres could be basically inhabitable now and changed by our intervention. We're in a situation where whatever we do, we really can't tell how we're affecting things unless we actually see that we've started a fire or irradiated something. It can be extremely hard to get all the data and all the facts. I think really right now, one of the best things going for us is the fact that we are aware that there are changes occurring all the time and that we're rapidly developing the technologies to literally build an archive of species. We've reached a point where we can take the genetic code of an animal and in many cases sequence it, break it down, and store it on a computer disk. One day, in the near future, we may actually be able to recreate a species from that information. And the case in point is the polio virus. There were some researchers who noticed many articles were published over the years studying polio. And they wondered if enough of the genetic sequence of it had been published in the articles, the magazines and the journals, that they could put it back together again from scratch. Now, realize they didn't have any polio in their hands or in a test tube in their lab, but they went back to the published articles. They put together all the gene sequences they could find. They successfully recreated the genetic code, and they put it in a gene machine, which builds up the strand of DNA or RNA base by base, just like building a sentence out of letters of the alphabet. When they were done, they injected this newly created genetic sequence into some cells, and they came down with polio. They actually recreated the polio virus from magazine articles. So that proves that it can be done. It has been done. That means if we can improve our methods, gain a better understanding of it, we literally stand on the verge of being able to take a species and resurrect it using nothing but its genetic code. That could be a wonderful thing, because if we ever reach a point where our environment is destroyed or damaged severely, if we properly apply ourselves, we could resurrect animals that were destroyed in the process. All we need is their genetic code.
Kind of like a Noah's Ark, huh?
Very much so, and it might fit on a flash drive in your pocket one day.
Yeah. Is there anything else, Sir Charles, that you want to get out there? If so, by all means, go ahead. And
Well,
I
sure.
do want to thank you so much for taking the time out to be with us tonight. But I want to give you a chance to get into whatever you'd like.
Absolutely. I've got a couple of books that I think people would be fascinated by. They can find them on the website or on Amazon as Kindle downloads. I've got the Living Galaxy, where I discuss different solar systems and the possible biospheres that might exist there. I talk about different types of stars, different lengths of day and year, the different sorts of worlds and chemistries we might find, and the fact that life should be probably everywhere in our universe. And the other one is, of course, The Fossil Hunter's Guide to Mars, which some of your listeners are familiar with. There's over 400 pages of fossils, chemistry, physics, NASA, everything you need to know about it. And I think that this is a sort of book that anybody who's taking a university course would really enjoy. The references are very deep and extensive. So they can find those on my site, or they can just search for them in Google.
Okay. Well, great. And we've got you linked up over on latenightinthemidlands.com as well. It's been fun talking with you. I appreciate you taking the time out. I really do, and I hope we could talk again in the near future.
Well, thank you. I'm looking forward to that. Thank you very much, Michael.
All right. Thank you very much, and enjoy the rest of your evening. Sir Charles Schultz at latenightinthemidlands.com. Did post those pictures that you had sent me on latenightinthemidlands.com. If everybody goes down to the bottom of the website, on the main page, I have a picture slider. And there's some pretty interesting photos down there. And there are fossils, I believe. But now you claim to have found fossils on Mars. Tell me a little bit about what you found. And I think that's just the most interesting aspect of Mars, I think, right now is all the stuff that people are able to, because with the technology we have now, to be able to go through these photos. I've seen some pretty interesting stuff, and what you got is pretty interesting as well. So if you could tell us about them.
Well, certainly. Back in 2004, I was doing some research for a project. We were going to build a rover of a sort that school groups and colleges could log in online and run a simulated mission. And in order to make it as realistic as possible, I was studying the images coming back from the rovers when they'd first landed. And I found what, to me, very clearly looked out of place. Now, I'm an avid rock collector and fossil hunter, and I have been since I was a child. So there were some things that in my eyes didn't look right. And when I started looking, you could see signs of what appeared to be marine trash, bits of shell, that sort of thing. And the closer I looked, the more obvious it became. And so I did contact some people at NASA and discovered that they had a marine biologist, an oceanographer, on the team looking at the earliest images coming back, which was a very interesting piece of information. It turns out that the planet apparently went through the same sort of early history that the Earth did. And that shouldn't be too surprising because the chemistry would be the same. And very simple marine life showed up, and all of the fossils we find, to be very clear, are of a marine nature. Nothing basically that would have lived on the land. But when you think about it, on a planet where the atmosphere is so thin, anything alive is most likely to have an existence in an ocean because the water will act as a surrogate atmosphere. It will carry the gases that you need and the nutrients that you need, and you won't be exposed to near vacuum. So it made perfect sense, and the more we looked, the more we found, and everything was consistent. And NASA's stance has been very curious. Even though they admit they had people who studied and found traces of clay that were formed in the presence of water, it was able to measure the amount of dust that was deposited because it had the camera right on the surface, and it was also able to measure take some wind measurements, and they never really saw anything over around 70 miles per hour under any circumstance. So while there are dust storms, the air is extremely thin, and even when the wind is blowing at high speeds, it doesn't have a lot of force. It's sort of like the difference between walking through a stream of water at 3 miles per hour or standing in the wind at 3 miles per hour. The water is so much more dense it can almost carry you along. Well, the difference between the atmosphere on Earth and the atmosphere on Mars is similar to that. It takes an immense amount of wind speed to carry any dust on the planet because the air is so much thinner than it is here on the Earth.
Now, why is the air on Mars so thin compared to our own planet? I mean, what's the difference? The size of the planet?
In fact, that's a very good part of the answer. The planet is so small that if you were to stand on the surface of Mars, you'd only feel about 38% of the gravity that you do on the Earth. So for something that weighed 100 pounds on the Earth, it would only weigh 38 pounds on the surface of Mars. Well, gravity is one of the major factors that keeps the atmosphere surrounding a planet. Without it, gas molecules that are hotter than the others will fly off into space literally by like a process of evaporation, and the air gets thinner and thinner. There is a satellite orbiting Mars called the Aspera 3, and it measured the rate of gas loss from the Martian atmosphere, and it loses about 100 tons of gas per day. Now, the Earth, of course, has much more gravity than Mars, but we also have another advantage, and that is volcanoes. Volcanic activity replaces the water in our oceans and the atmospheric gas in our atmosphere. So because Mars is basically geologically dead inside, it doesn't have any volcanism, so it can't replace its air or its oceans.
Oh, I think we just came up with the solution for the obesity problem.
Less gravity? Well, maybe.
Yeah, bring them to Mars. They'll feel better about themselves and they'll, maybe take shape. I don't know. They say there's a problem with that. What about oceans on Mars? Has there ever been, or is there now, any type of evidence of oceans?
Actually, yes. In the past, that was a big controversy, whether there ever could have been oceans, to do with how light is scattered by air molecules, not by what it's made of.
I didn't know that.
Well, and
I'm getting an education.
Well, that's a good thing many times. But a lot of people think it also is associated with the presence of water, and it isn't. But we can see something very interesting, and the Martian atmosphere does have clouds quite commonly. On the surface, there's often fog, snow, dew, and other forms of precipitation. But when we look at the clouds in the sky, NASA often tells us that it's ice crystals, water ice. But the Hubble's telescope tells us otherwise. If you look at light, light sometimes has a property called polarization, and Polaroid sunglasses take advantage of that to cut glare. Well, ice crystals and water droplets each do a different thing with light, and the ice crystals don't polarize the light, so when the Hubble sees them, the clouds are not polarized. But water droplets do polarize the light, and half of the clouds that Hubble sees in the Martian atmosphere are water droplets, so it's liquid water and not frozen ice crystals.
Oh, wow. So then what happens? Does it hit the ground and then freeze, or does it never hit the ground?
Well, actually, it can. You'll remember the Phoenix lander that went to the Mars North Polar region a few years back, and it landed there and sent back some fascinating material, including the fact that they'd landed right on a sheet of ice that was buried under about 1.5 inches of dirt. One of the scientists on the team claimed that, yes, well, it could snow in the Martian atmosphere, but it would never reach the ground. Well, when winter came and the Phoenix shut down, they couldn't find it until after the snows had gone, and they found that the solar panels on it had collapsed, and that clearly was from the weight of snow that had landed on them. So we know that the snow can reach the ground, and the other proof is the fact that there are polar caps, so snow must be landing on the planet.
Oh, wow, that's interesting. Now, what's the weather like on Mars? I hear they get 300-mile-an-hour windstorms. Is that true?
Well, actually, no. We had two very good weather stations on Mars back in 1976, Viking 1 and Viking 2, and those landers carried wind speed meters, and no matter what, they never saw a wind greater than 74 miles per hour. And even with the recent Mir program, Opportunity and Spirit, when the dust storm struck, Opportunity was
Mars. That is a hot topic, especially for me it is. You know, I've always believed that there's more to Mars than just a dead planet. So tell me this, what is Mars like? And maybe give some of the similarities to Earth. Maybe compare the two.
Absolutely. If you look at the Earth and Mars, Mars is roughly half the size of the Earth, but it's a terrestrial planet or a rocky planet. So we only have 4 terrestrial planets in our solar system, and Earth and Mars are 2 of them. Mercury and Venus are the other 2. The rest of them are basically gas giants, so there's a lot of atmosphere and little or no solid ground. So Mars and Earth have a lot of similarities also in chemical composition and history. They were made of the same materials at the same time in the solar system, and so much of their material inside the planet and on the surface of each planet is very similar. The chemistry is basically identical, except we're dominated with oxygen and life, and Mars has a very thin atmosphere, nearly a vacuum, but it still has sky, clouds, precipitation, and weather just like we do.
I see. You know, I've seen a lot of pictures, and lately people have been sending me these pictures that color was added to, I guess, and they say that the photos that we have gotten back are not real and that there's actually oxygen, blue skies on Mars. I don't know. What has NASA's research done in the way of the way we view Mars? I mean, is it can we have any faith in any of the information they give us? Because I know a lot of people are skeptical.
Well, we can have a faith, quite a bit of faith in most of it, and a lot of it you can verify for yourself in a fairly simple manner if you have some science background. We do know that the atmosphere is very thin on Mars, but we also know that the sky is often blue. Many people will think that that has to do with oxygen, but it really doesn't. If you had a pure, dry gas atmosphere of nitrogen or of helium or of oxygen or of almost any non-reacting gas, you would basically find the same thing, a blue sky, and it has to Mars. But when you take the orbital pictures from the satellites with the cameras that are in orbit around Mars now, you can see numerous river deltas and places where water has washed over the plains and left valleys and rills. You can see some areas that even today appear to be brine lakes here and there. Those would be very hard to evaporate and get rid of, or even to freeze because of their composition. But it is proven that there were huge oceans on Mars in the past, and that maybe up to half of the planet might have been covered by water. In the area of Opportunities Landing, Eagle Crater, that particular area in Meridiani, they found that the water might have been anywhere from 10 to 50 meters deep, and that's 33 to, call it about 160 feet of water on the planet. They also did a survey of the ice in the craters in the North and South Poles and also in the polar caps, and found that just below the soil there's a huge quantity of water ice today, and if it were to melt, they could give an average water depth of about 50 meters all over the planet. So the oceans never left. They're frozen. They're like glaciers right now. The Mars that we see today is really one in an ice age, and it's been frozen like that long enough that that orange dust all over the planet has covered all of the ice sheets.
Oh, wow. So how can they tell how much of it is ocean? I mean, how are they able to determine that?
Actually, that turns out to be fairly simple. If you look at the map of the Earth with the water removed, you will see how the continental shelf, where the ocean basins are, has a different quality from the higher dry land that we know of today. And so the geometry of the land has been sculpted by the presence of water. And in many cases, you can see where, let's say, a river has run downhill, created a delta, and fanned out into the sea. It leaves a very characteristic series of riverbeds and curving valleys and channels behind it. And we see those same features on Mars in many areas. And in fact, the Curiosity rover, the Mars Science Lander, is presently in one of those areas, and it's known as Gale Crater. So they can see where the water pooled in the crater and exited and left basically running riverbeds dried up in its path.
That's amazing. Now, I